Survey of solvent selection guides. As explained in the previous paragraphs, there is no clear definition of solvent greediness. This is why solvent selection guides have been elaborated by pharma companies or institutions in order to help their chemists in their choice. The assessments are based on occupational health, safety, and environment criteria, but also on other constraints, industrial issues, ICH levels, cost, regulations, and so on. A solvent guide reflects the policy of its company or institution. Hence, there are different structures, wording, and weighing of criteria. In order to compare the different guides, we have built a methodology and established the level of convergence for the ranking of classical solvents. The comparison of the published solvent guides is not easy at all. Pfizer and Sanofi guides give clear rankings for solvents, but the wording and number of levels is not the same. AstraZeneca and the Farmeron table guides are similar. They do not give a clear ranking and they score the criteria from 1 to 10, but the numbers of criteria are different. GCI guide is also similar but more complex, with legislation and EHS flags. Moreover, the scoring order is opposite to this of the former guides. The survey of solvent guides was made on the 51 more represented solvents. In order to facilitate the comparison, the number of criteria in each guide was reduced to 3, one for safety, one for environment, and one for health. Let's take the Pharma Roundtable Guide as an example. It has 1 health, 1 safety, and 3 environment criteria, each scored from 1 to 10. The health and safety scores are unchanged, but one needs to combine the 3 environment criteria. For this global criterion, the score will be the highest, that is to say, the worst, of the 3 original environment scores. For ethanol 6, for terbutanol 7, and for hexane 8. Each guide has now only 3 global criteria. Let's continue with the Pharma Roundtable Guide. An overall scoring can be given from the HSE scores based on their sum. For ethanol, 3 plus 4 plus 6 gives 13. For the ranking, one calculates the arithmetical mean, here 16. 3 solvent groups of similar size are built around this mean, with a classical 3-color code, green, yellow, red. The scoring comparison is now very easy. The figures do not matter, nor the ranking wording. Only the colors matters. If there is a large majority, the overall ranking is clear, recommended, problematic, hazardous. If not, the ranking is to be confirmed, either between recommended and problematic, or between problematic and hazardous. The less desirable solvents are ranked as highly hazardous. In order to align with regulations, we have integrated additional criteria based on CLP hazard statements. If the solvent is hazardous for ozone layer, statement 420, the solvent is ranked as highly hazardous. If the solvent is carcinogenic of category 1, it is also ranked as highly hazardous. If the solvent is reprotoxic of category 1, it is at least ranked as hazardous. One ends up with this table, in which 2/3 of solvents have a clear ranking: recommended, problematic, hazardous, or highly hazardous. The other solvents are in between. This work has been published in Green Chemistry in 2014. In conclusion, a large majority of solvent is unambiguously ranked by most solvent guides. Regulation constraints help flagging the hazardous solvent. 1/3 of the solvents could not be ranked by this methodology. This reflects the different perception and weighing of criteria in the guides. Debate between experts are needed to establish some rankings, in particular for the borderline solvents, or to flag a solvent as highly hazardous. In the next paragraph, we will present the Chem21 solvent selection guide, which was elaborated to rank these borderline solvents.